Hello juniors, today we're going to continue with electronic assignment number 7, which is about the sine rule, and today we're going to see the ambiguous case triangles, which is a particular case that only appears when we work with the sine rule. Okay, so we're going to do this investigation. It says, try to draw the triangle ABC where we're given this information. Angle A is 32 degrees, side A is 3 centimeters, and side C is 5 centimeters. And here's the important part. You should find that there are actually two possible triangles that fit this description. So this is one case. You see, let's zoom in here for you to see. You see that we're respecting all of the information. We know that angle A is 32. We know that side A, the opposite to 32, is 3. And we know that this side C, is 5. So this triangle is actually fulfilling with all of the data that we're given in the problem. But I can also build this triangle, which also fulfills the requirements. We see that we have angle A, we have side A, which is 3, and we also have side C, which is 5. The only difference is that now side A, instead of being like this, with this inclination, it's with an inclination to the other side, right? So we get different values of side B. But both of the triangles are correct, right? Because both fulfill the requirements done by the problem. If I try to overlap both, you're going to see that, for example, this would be side C, which is 5. We would have side A somewhere around here, which is 3 centimeters. 3 centimeters. And, well, this would be side B, right, which we don't know. And this is 32 degrees. So you see that I can build the other triangle right here. Maybe this could also be 3. You see that I'm drawing here an isosceles triangle where this side is the same to this side, right? So this option is also valid, right? We have two triangles here, the red one and this green one over here, right? So those are the two different alternatives that can be presented with the same information. And as I told you, both triangles are actually correct. Okay, so how do we work in these cases? It says, the given measurements do not describe a unique triangle. Number 1, find the size of angle C in each of the triangles. Call them C1 and C2. What is the relationship between these two angles? Okay, so let's work with both triangles. For that, I'm going to move this a little bit more. Let's work with both triangles independently and solve each of the triangles. We want to find angle C in both cases. So how do we find this angle in this particular triangle? I would have to apply sine rule, right? We already have this side and we have this pair of values. So we can apply sine rule. We would say that 5 is to sine of angle C as 3 is to the sine of 32 degrees, right? Sine of 32 degrees. If we solve this using calculator, you would get an answer. We're going to call this C1, which is equal to 62.03 if we round this to 2 decimal places, okay? So that's the first angle, 62.03 degrees. Now, let's work with this triangle. We're actually going to be doing exactly the same thing, right? We're going to apply sine rule. We have this side and we have this pair of values. So I'm going to say that 5 is to sine of C. I'm going to call this is C1, this is C2, as 3 is to sine of 32 degrees. 32 degrees. But if we solve this, we're actually going to be getting the same answer, right? Because we're doing exactly the same process. So we're actually going to get 62.03 degrees. But take a look at the angles. This one over here is an acute angle, while this angle over here is an obtuse angle. So that means that the value of C2 cannot be a value less than 90 degrees. It must be a value greater than 90 degrees, sorry. So that means that the value of C2 is going to be calculated in the following way. I'm going to add something here. We're going to find the the supplementary angle of 62.03, which is found by doing 180 minus that angle. And then we're going to get the real value of this angle, which is 117.97 degrees. So this is 117.97 degrees. Okay, so let's keep on working with the investigation. It says, what is the relationship between these two angles? As I told you, this angle and this angle both add up to 180 degrees. And when two angles add up to 180 degrees, we say that the two angles are supplementary angles. So that's the relationship. Let me write this down. We're going to say that both angles are supplementary angles. Okay, so that's a very important thing you should consider whenever we're talking about ambiguous case triangles. Then for part 2, it says, using these angles for C, find angle B and the length of AC for each triangle. This is known as the ambiguous case, and it can sometimes happen when you are given two sides and a not included angle of the triangle. Okay, so to avoid wasting too much time, we're gonna skip this part, but you already know how to find this side using this triangle and this side using this triangle. We're gonna apply, well, first of all, we need to find this angle over here, which you know how to calculate, 180 minus the addition of these two. And then after having this angle, we can apply again sine rule to find the missing side, right? And exactly the same process is gonna be done here. And you will get different values of B, right? This B over here would be longer than this B over here. You can clearly see that in this drawing over here. If I change this, you will see that from here to here, we're gonna get one value of B. I'm gonna call this B, this is actually B2, and the whole thing would be B1, okay? B2 corresponds to this triangle over here, and B1 corresponds to this triangle over here. Okay, so you see that you should be getting different values of B when solving for this second part. Okay, I'm leaving a YouTube video here for you to understand more in depth what the ambiguous case is about. It's a really interactive video. I encourage you to see this, and it explains the ambiguous case more in depth. Okay, but this is the most important thing that you should remember when talking about the ambiguous case. Sine of A, if sine of A is equal to sine of B, then we say that angles A and B are supplementary angles. You see that the sine of this angle over here is the same as the sine of this angle over here. You can try that in your calculator and you'll see that you get the same result. So that's always a case. When angles are supplementary angles, the sine of both angles are the same. Then it says, the ambiguous case does not occur every time you solve a triangle. So these are the conditions that need to be met in order to have an ambiguous case. It says, there can be an ambiguous case when you use the sine rule if, number one, you're given two sides and a non-included acute angle, which is this case. We were given two sides and a non-included acute angle. Not included means that the angle is not in between both sides. If it was in between, it would have been this angle over here. But we were given two sides and this angle over here, which is a non-included angle. Or if the side opposite the given acute angle is the shorter of the two given sides. Okay, actually the two conditions must be met in order to have sine rule. So it's if you're given two sides and a non-included angle, and the side opposite the given acute angle is the shorter of the two given sides, which is exactly what we had in this particular situation. Okay, so let's see an example together in order to finish this assignment. We're gonna see one example about this ambiguous case. It says, in triangle ABC, angle A is 40, side A is 14, and side C is 20 centimeters. Solve this triangle giving all possible cases. So this is a suggestion that we may have more than one triangle, right? Give your answers correct to 1 decimal place. So if we draw this situation, we would see that we have angle A, side A, and side C. So this is exactly the ambiguous case. If we draw this, we're going to have, let's draw first side C, for example. This would be 20 centimeters. And we're going to draw here a straight line to there, for example. Let's do a little bit shorter, maybe up to there. So we're going to have two possibilities. Either this angle would be 40 degrees. This is A. We would have B right here and C right here. So if we, two possibilities, either side A could be right here, which would be 14 centimeters, or we could have, let me do this with maybe blue. We could have side A right here, right? This could also be equal to 14 centimeters. So here we would have two possibilities. It would be C1 and this could be C2, okay? Two possibilities for point C on this triangle. Okay, so let's solve this triangle. To solve the triangle, we need to find all of the angles and sides of the triangle, right? So maybe for this side B, we would have two possibilities for side B, right? In one case, we would have that, for example, from here to here, we would have, this would be B2, and from here to here, we would have the other possibility of B, which is B1. B1. Okay, so let's focus first on triangle. Let's solve triangle ABC1. We're gonna focus on the big triangle first, okay? To solve that triangle, I see that we already have this side, we already have this side, and we have this angle over here. So I can apply sine rule, right? We would say that, for example, 14 is to sine of 40 degrees as 20 is to sine of C1, angle C1. So if I solve this, we're going to get angle C1. If you do this in the calculator, you should get a value of 66.7. We're going to round this to 1 decimal place, okay? So we're rounding this to 1 decimal place. So there we have. This is one answer for solving the first triangle. So let's complete that information here. This angle C1 is 66.7 degrees. You see that it seems to be correct because it's an acute angle, right? It's not greater than 90 degrees. Then, if we keep on working with the big triangle, ABC1, then I can find, for example, this complete angle over here. We're going to say that angle B, the angle B would be equal to, I'm going to call this B1 as well. B1 because we're going to find two angles for B. It would be 180 minus 66.7 plus 40, right? So here we're going to get angle B1, which would be equal to, if we solve this in a calculator, 73.3 degrees. Okay, so finally, I'm only missing side B1, right, to solve this triangle. So to find side B1, we can again apply the sine rule. Let me see if I can get a little bit more space here. Take this up. There. Okay, so to calculate side B, this is an answer. To calculate side B, I'm gonna again apply sine rule. We're gonna say that B1 is to sine of angle B1 that is angle B1, we already have the result, 73.3 degrees, as we can use anyone. I'm going to use A. As 14 is to sine of 40 degrees. Sine of 40 degrees. Maybe I can take this down. I'll take this down. There. Okay, so if I solve this using a calculator, we're going to get this side we're missing, right? Side B1, which is the longest side, which would be equal to 20.9 centimeters if you do this in a calculator and round it to 1 decimal place. So there you have the answer for B1. Now, we're done with the first triangle, the big one. Now we're going to be working with the other triangle. Triangle A, B, C2. Triangle ABC2. Okay, this is one triangle, this is another triangle. So if we work with triangle ABC2, we're looking at this triangle over here, right? So first thing we need to do is we need to calculate this angle over here. If you take a look at this image here, you would clearly see that angle C2 is actually the supplementary angle of 66.7. Why? Because if you take a look at this angle here, you see that this triangle over here, C2BC1, is an isosceles triangle. Why? Because this side is 14 and this side is also 14. So if it is an isosceles triangle, it has two same sides, and by consequence, it will also have two same angles. This would be 66.7 degrees as well, right? Because it's an isosceles triangle. So for that reason, this angle over here must be 180 minus this, which is a supplementary angle, right? If we do that, then we're going to get angle C2. So we're going to say that C2 angle is equal to 180 minus 66.7 degrees. So we're going to get that C2 is equal to 113.3 degrees if we round this to three significant figures. So this is this angle over here, 113.3 degrees. So we can say here that angle C1, just to make this clear, is the supplementary angle, angle of angle C2. Okay, so we already have that angle, so now we can solve this obtuse triangle over here. So we're going to say that we're looking for, first of all, the angle B. We're going to call this B2, and then we're going to find side B2. Okay, so B2 angle. To find this angle, we already have the other two angles, so I can do 180 minus the addition of both, 40 plus 113.3, and we're going to get angle B2, which would be equal to 26.7 degrees. Okay, finally, we would find side B2 by applying sine rule. We're going to say that side B2 is to sine of 26.7 as, we can use, for example, angle A in side A as 14, which is side A, is to sine of 40. So if you solve this, you're going to get side B2, which should be a value smaller than B1. If you do this, you would get a value of 9.8 centimeters if we round it to 1 decimal place. So you see that it's actually smaller than this value over here. So that means that we're doing the right thing. Okay? So that's it. We have solved both triangles, and this is the ambiguous case, right? From the three pieces of information we were given, we were able to build two triangles which have different angles and sides. Okay, and this is the result. Let me change this. I think this was fine like this. There you go. So this is the result of the ambiguous case. So I think that's it. Yes, I hope this was clear, juniors. If not, please let me know. Please remember to watch this video. It's a really interesting video to finish understanding what the sine rule, that the ambiguous case is about. Okay, So let me know if you have any doubts, and see you in future live sessions.